Are you ready to solve some log equations? If you said yes, you're in the right place. Let's take a look at some of the type 1. And I think the category is nice. When they call it a type 1, it just means that the logs are only on one side of the equation. So that kind of matches up. So when we go to this, the idea is trying to first see, do we have a single log? And if example 5, you notice, oh yes, we do have a single logarithm. And luckily the x is already isolated. It's just a matter of us solving. So sometimes when we see this, we can just say, well, this log base 4, keep in mind, I do have a type 1 just because we see the log is only on one side. But it's really a matter of log that has a numerical base, which is 4, and a numerical argument, 16 over 5th root of 64, whatever that happens to be. We may want to see if this ends up being a nice number. So right away, that base that's a 4, it kind of gives me a clue, is that maybe I can play around with some of the algebra behind this. And I'll use that base 4 to maybe say, what happens if I rewrite 16 as base 4? And we've kind of been playing with some of these already. That 16 is really 4 square. And then similarly, we also realize that 64 is also a power of 4. It's 4 to the power of 3. Now this is fresh in my mind from a previous example. However, if you don't remember the powers of 4, just, use your calculator off to the side and test these things out. No shame in that. I'd rather be accurate than fast, right? Now, the purpose behind this is just kind of understanding that if everyone is in terms of base 4, I might be able to simplify this argument a little bit nicer. And right away, I don't know if you kind of caught on this yet, but when we do see radicals in a logarithmic expression, a lot of times we like to rewrite those radicals as rational exponents. So you'll see me, if I look at 5th root of 4 cubed, you might see this rewritten as 4 to the 3/5. And I'm starting to see my argument become a little bit nicer. So then I can simplify my argument a bit by noticing that I am dividing with the same bases. 4 squared, 4 to the 3/5. And whenever you divide with the same bases, you keep the bases and you subtract the exponents. So what that means is we end up getting 2 subtract off 3/5. So it allows us to now have a nice, non-fraction argument. And I wrote this extra step just to keep us, sometimes fractions kind of intimidate me. So I just want to remind myself that I'm saying, what is 2 take away 3/5? So I have log base 4 of 4 and 2 minus 3/5. You can either pull up your TI. Let's do that. We have enough problems to worry about with remembering algebraic concepts already. Might as well make it life a little bit easier. So I'm gonna just say, well, let's use the fraction key. So what do we have? It was, if I remember correctly, it was 2 minus 3/5. I'll double check one more time before I see anything. Yes, 2 minus 3/5. So we can type that in quickly. I'll probably use the math key to turn it into a fraction. And that gives me 7/5. So I'll go back. And 2 minus 3/5 became 7/5. Now at this stage, I kind of am seeing this whenever, so another property of log that comes back to us, whenever the base matches the base in the argument, the answer is what the exponent was or what was different. So finally, we can say that this expression is really just 7/5. So x is really just 7/5. So that's kind of a nice way to use properties of exponents, a nice review of some algebra with the laws. There's a lot of algebra involved there. I'm thinking your TI can probably handle this and figure this out without us going through this, but you never know. Sometimes this instructor removes the use of the calculator, so it's good to be able to work around this. Good exercise for our brains. So one more type of problem, a little more common, that we end up seeing in this type 1 equations. Sometimes you will see maybe a sum or difference of logs happening in your equation. And remind myself again, I do see logs on only one side of the equation, so it is still type 1. When I run into this, the first thing I'll ask myself is, do they have the same base? This is me talking to myself. Same base? And my answer is yes, the base is 10. So sometimes, you know me by now, you see me write these in, even though we don't have to. If you can notice that they have the same base, you can now incorporate properties. So if you guys remember, if you have a sum of two logs, so what do we have, log base b of x plus log base b of y, you can condense into a single log where the arguments end up being multiplied. So that is the property we are going to apply. I'm going to convert this left-hand side, log base 10, and what happens to the arguments, they will be multiplied. So we have x times x plus 3, single log, still equaling 1. Well, if it makes you a little more confident, sometimes you can say, well, this x times x plus 3, I know it's not 0 on one side, so unfortunately, it might be better, log base 10. Let's distribute the x and just kind of give ourselves the idea of what the argument really is. So x times x is x squared, x times 3 is 3x. So we still have the logarithm equal to 1. Now, the reason why we like to condense everything to a single log is because we can now convert it to exponential form. And what that does for us is it takes out the log, it takes out the complication in the equation. Now, when you convert to exponential form, remember, you have to keep in mind who the base is. That's why I kept writing it. Catching on to me at this point. So I take 10 to the power of 1, and that should be equal to whatever the argument was. So that's x squared plus 3x. Well, 10 to the power of 1 is just 10. If it was another number, we'd have to simplify. But we are now getting what we seem to understand as a quadratic equation. This is nice. We like solving these. And so with quadratic equation, you may be used to this by now. You're moving everything to one side with 0 on the other. And then we're just asking ourselves and hoping that this will factor nicely. So if I kind of double check for myself, I'm looking at factors of -10 that add up to 3. 5 times 2 is 10. To add up to +3, I think I'd have to have the negative on the 2 part. Very happy to see that the coefficient of the square term is 1. So that means we can put an x in each of the binomials and use the factors as is. So we have that factorization. We then get, I'm going to move over here just to have a little more space here. Us setting the factors equal to 0 for us to solve. It's just habit. I know a lot of you can skip these steps, but I like to show it if I'm making a video. Why not, right? Adding 2 to both sides, we have x equals -5 or x equals 2. Now, one last thing to double check. We always want to make sure that the solutions that we pick do not make any of the log arguments negative. So it's not the fact that we have a negative solution. It always matters who the arguments are. I have to emphasize that. Don't automatically throw them out if they're negative. It just happens so in this example. Notice if you're looking at the original equation, and I will write it over just so that you see, log of x plus log of x plus 3 equals 1, you're checking the arguments. You don't have to really check it back into the original equation unless you feel the need to. But if you were to try out x equals -5, right away, you would see log of -5. And if you try to type that in your TI, go ahead. You notice what happened? You got an error. And the issue is that the log argument was negative. And by definition of log's exponents, you're not allowed to have a negative argument. You can have a negative solution to an equation, but not a negative argument. So I don't have to continue plugging it in. The fact that it made one of the logarithms have a negative argument, it's safe enough for me to say, I can't use this solution. So I need to throw out x equals -5. Now just double check this with 2. We'll do this verbally. If x equals 2, log of 2, that's a positive number, we're good to go. Log of 2 plus 3, 2 plus 3 is 5, a positive number, we're good to go. We actually have our solution. So you can circle it, or maybe if you are interested, you can say, hey, my solution. Use little fancy braces to include it's just the number 2. So that is the solution to this type 1 log equation. Just kind of be careful at the very end to double check your arguments. Practice, practice, practice. That's what it takes to be successful. Take a few moments to try some of the homework problems, and I will see you for the next challenging examples.